Howdy, y'all. Professor Parks, PhD here. Welcome back to the channel. Last week, I had the opportunity to sit down and have a conversation with Austin Witsit, a prominent voice in the flat Earth community. This conversation was held on his channel, Witsit Gets It, but he allowed me the opportunity or the permission to mirror that conversation onto my channel. And so this is the first part in 3 of that entire conversation. The conversation ran roughly 4 hours, so I wanted to break it up into easily digestible chunks, as it were. The conversation was free-flowing, or was not formatted. It certainly wasn't a debate in any way. It was, in my opinion, an attempt as a meeting of the minds, because as an astronomer, I wanted to know specifically what it was about the mainstream narrative, as it were, that Austin rejected. What was basically, where was he from? Or where is he coming from? Because he certainly does not hold that the universe is the heliocentric, what they refer to as the heliocentric model, with the Earth revolving around the sun going around the center of the galaxy, and the galaxy being one of multitude of galaxies in an exceedingly old universe. I'm not going to put words in his mouth. I'm not going to tell you what he believes. I will let the conversation speak for itself. But I think that's ultimately what this conversation was about on really both sides, was to try to come to an understanding of what it was, why it was that we hold to the ideas that we have. And so I hope these conversations, or this conversation, these videos, I hope you find them interesting. I hope they shed light on both my mindset, his mindset, and really just give a better look, a more neutral look or objective look at the flat Earth conversation. All right, peace out, clear skies.
All right, thank you for having me on, and I'm kind of honored to be your first guest. You can call me Rob. That's generally what I go by. Robert is actually my middle name. But just to introduce myself properly, I'm Dr. Rob Parks. I'm the Deputy Director of the George Mason Observatory and its public outreach lead. My PhD is in astronomy, and my expertise is in stellar magnetism and young stellar objects, or protostars, if you'd like. But I've dabbled in other things.
Okay, nice. So you, I know you said you're a professor and you've taught a few different places. So, like, what do you teach? What have you taught?
What have I taught? So I have taught anything from physics recitation, which means one-on-one with students, getting them through algebra-based introductory physics. I've taught introductory physics labs, introductory physics or astronomy labs, advanced astronomy labs, advanced physics labs, and then lectures. I teach introductory astronomy, either in a one semester course or split up between 2. I've also taught the other major one that I've taught is introduction to cosmology, which is a undergraduate qualitative analysis of, or description of, cosmology. There's a little bit of math, but it's primarily just a, like I said, qualitative description.
Okay, cool. So we have had a couple brief conversations before, so we're not entirely new to each other. So basically your focus is astronomy primarily.
Yes.
Right. Okay, cool. So let's see, how should we start the convo? Do you, I guess obviously you know that here on this channel we are quite skeptical of claims about space.
Yep.
I will say it this way, I certainly don't think your job is just a big cabal of people lying or anything like that. You know, I definitely don't think that. I just think that a lot of people have some ingrained presuppositions about the sky. So that's kind of where I'm at. So I think we may not disagree as much as some people may think, but we are certainly not going to agree on a lot of things. Let's see. How about this? If you want to, I can just kind of give you the floor to kind of explain why you feel that that astronomy, as it is in modern times understood, is legit. Does that make sense? Like, just kind of explain what it is so convincing for you that you guys have a proper understanding of the sky.
Okay. Yeah, and actually, that was one of the things I wanted to ask you about was whether or not there was a large cabal, influencing things or controlling things. Because I know from the Flat Earth side, there's a lot of emphasis on NASA. And to be perfectly honest, while NASA helps facilitate astronomy, in terms of actual astronomical research, that's not really exactly NASA's focus. Astronomy has been around forever. And so what leads me to believe that it's true, or that it's the best description so far, is just the sheer amount of work that's been done. I've gone through classes, I've done homework, I've been tested, I have done research on my own. All of that seems to be self-consistent with with what we put out there. What I hate to use the term mainstream science, but what mainstream science tells us, I found to be consistent. I have, I've worked with a lot of colleagues. I know just the American Astronomical Society, its membership is around 10,000 people. So it would be very difficult for me to understand if we are in fact misguided in some way. How is it that all of us are essentially misguided, or most they are misguided? Because I know there are a few people who hold slightly different concepts or views.
Yeah, so like I said, I think that everyone just has a presupposition, and certainly anyone alive now was born into those presuppositions. Like one of the most glaring ones being the Copernican principle. It's just not even up for debate. You'd be intellectually shamed if you question the idea that we are in motion around the sun, much less that the universe is huge and we're insignificant, basically. And that is a philosophical bias, in my opinion, right? And so if I look at the sky and I'm like, oh, that's a vacuum, everything's super far away, I'm flying through there at different speeds and different directions, and then you interpret everything from there, I don't think anyone's lying. I just think that they're forcing their interpretation without even realizing it. So that's how I view this whole thing. I looked into the history of heliocentrism, and specifically towards the beginning of the 20th century, we had some pretty astounding discoveries in terms of astronomy, and never once did they reconsider heliocentrism. They just moved the goalposts to now we're in a situation where, everything looks like we're in the center. That's the current. There is no center, and we're all going to look like we're in the center. And so that's how I view this whole thing. Basically, is a bunch of people they're doing their best to interpret what they see within the paradigm, and never really do they step back to question the foundation of the paradigm. So yeah, I don't put malevolence on it.
Okay. Oh, interesting. So it's interesting that you say the Copernican principle is a supposition or presupposition, or what have you, because we believe that the anthropomorphic principle, which is stating that the humanity, from a scientific standpoint, holds a unique or special place in the universe, that is in fact the presupposition, because that is essentially what Aristotle held. And Aristotle was challenged because the idea was that if we are going around if he's wrong and we are going around the sun, then we should see stellar parallax. At the time, they didn't, and so they had two options. They could either say the stars are very, very far away, and so there's no way that we can detect parallax with our eyes, or the Earth is stationary. They obviously chose the latter. When it came to Copernicus, the problem was you had this observational crisis with Tycho Brahe's observations of Mars, and Kepler trying to, well, I'm getting a little ahead of myself. You had this observational crisis that the Ptolemaic system was becoming extremely bulky, extremely hard to use. And so Copernicus wanted to basically set about trying to simplify it. Because one of the principles behind the Ptolemaic system was that the planets existed on actual solid spheres, which given epicycles, that's not physically possible. And then on top of that, after him, you had Kepler, who, you had the observational crisis of Tycho's observations of Mars, that 8 arc-minute discrepancy. And so that brought us from a heliocentric circular universe to a heliocentric elliptical universe. So we've had observations and knowledge of the fact that we are in a heliocentric universe for hundreds of years, and I would push back on the fact that we have not challenged that. Yeah.
You heard me though, right?
Yeah, I heard you.
Okay, yeah. Just to repeat real fast, I'm saying I think we have a bit of a revisionist history. Galileo wrote a letter on his, before he died, denouncing heliocentrism. They had his name erased, and no one's ever heard of that. And then Copernicus himself said that the heliocentric model, it doesn't matter if it's true or even plausible. It's just convenient to explain phenomena. I find that that's not what we're told. I mean, Copernicus didn't have a telescope. Right. He did this with his naked eye. He didn't have some astounding observation or anything. Whatever. I think that it's back and forth. It's like, oh, what are we doing? When we get up to the 20th century, though, everything changed. Michelson Morley threw a wrench into everything. Right. I mean, I can show you endless quotes from Albert Michelson himself, from Einstein, from Arthur Eddington, Wolfgang Pauli, you name it. It's like, oh, it looks like the Earth could be at rest, and we changed all of physics. We just changed all of physics, and we said, and then in 25, Hubble, I'll let you kind of, in 25, Hubble looks out there and he's like, oh, there's not any blue shift anywhere. It's all red. Why is everything red? Yeah. Well, there should have been blue shift, and there wasn't really blue shift. So then they said, oh, well, everything's accelerating away from us. Look, can I ask you like this? Let me ask you this, and then I'll give you plenty of room to just kind of tell me what you think about this. So leading up to say Hubble's observations, you have the idea of the Earth being in the center and the idea of it going around the sun. And the idea of us in this huge universe going around the sun, it's logical to think, oh, well, you're just going to see chaos everywhere. You're just going to see things going every which way. The Earth is insignificant. It's a little pale blue dot in the middle of nowhere. Geocentrism says everything is going to move in relation to us. It's going to look like we're at the center, and everything's moving directly in relation to where we observe it from on the Earth. We then make the observations, and it looks like the latter. So at that point, one theory was correct with its prediction, and one was grossly wrong. They didn't even consider the one that predicted what we saw beforehand. You see what I'm saying? It's a bias.
Okay, so there's a lot there to unpack. The thing about Galileo is, I guess I have 2 things to say about that. I don't know of that letter. If you send me a link, that'd be great. I do know that his published work prior to that letter, he was fervently a heliocentrist. In fact, he also is quoted as saying, that the Bible is a great book, but should not be taken as a scientific textbook or something along those lines. I think it was more of you should take the Bible as true unless science tells you otherwise. Copernicus, I'm familiar with this preface, and the reason why he put that preface in, and the reason why he published the book near his death, was because he was afraid of the reaction of the church. Because he knew that the church wasn't really happy with the idea of moving the earth out of its prime position. What else was there that you wanted to say? Hubble. So actually, it wasn't Hubble that discovered the redshift. It was actually Slipher. But Hubble combined Slipher's observations with his own observations of distance. And what he found was that in the local neighborhood, what we call the local group, you have proper motions dominate. So you do have quite a bit of blue shift, red shift variation. But once you got out to further distances, that essentially the Hubble flow, as it's now called, is larger than the peculiar or proper motions of the individual galaxies. I would again push back on the idea that Michelson-Morley said anything about the observation or the Earth being the center of anything. I know of only one quote by Einstein, and I believe that it's wildly been misinterpreted. And also another thing is, I don't really concern myself so much with quotes as I do with what the science is telling me, what the laws of physics tells me, things of that nature. And then something else, the last thing I find I really want to talk to you about was every science class I teach, every science class that I begin with the paleo blue dot quote from Carl Sagan, which I have on my wall. And he talks about, this is us. This is everything that we are. We are basically all the saints, all the sinners, yada, yada. We are all in this dust mode. And I tell my students, there are some that I've encountered that that take that idea and it leads them to believe that we are insignificant. I take it to be quite the opposite. We are it. We're humanity of all the vastness of the cosmos. Its scale and distance and size, or distance and time. We're it. I think that makes us remarkably significant. Because if the Earth were to, Thanos out of existence, the universe wouldn't have us anymore. So,
yeah, I get that. Like, you can't even believe in a heliocentric model logically without believing it was created. But the vast majority of people that believe in it don't think that. They think that the sun and the moon appear to be the same size is just a coincidence. And to think that we just happen to live in a sustainable zone, and to think that there's just the perfect energy density that the universe spreads out flat, and there's like endless amount of fine-tuning problems, right? I can't even fathom believing all that without saying God had to do it. But that's the craziest part about it is you can pretend that just because you throw a dice a million times, it eventually lands on the million-sided dice. Eventually, you get the Earth, and the people that are on the foundation blocks of this model, they were atheists, and in fact, they say point blank that like the idea of being in the center is horrific. And then they had the audacity, like Stephen Hawking, to pretend it makes them humble to deny the possibility. I have a geocentrism stream where I have 120 quotes. Like Einstein himself said that Michelson, his compatriot, he's writing a letter. He says, your compatriot Michelson proved that nothing happens on the Earth as if it's moving. Everything on the Earth always takes place as if the Earth is at rest. Point blank said that. He said no optical experiment can tell the Earth is moving. No terrestrial experiment can tell that the Earth is moving. And honestly, just a basic understanding of relativity itself. Like, who cares what Einstein says? Relativity says you can't prove that the Earth is moving around the sun. Right. And that is in direct response to relativity. Now, you can look at stellar aberration and parallax, and you can assume it. You can assume that we're moving and this causes the stuff in the sky, but you can't actually detect it. No experiment can detect it. So that's where I don't understand why we act like we know it. Why we teach 5-year-olds that we know it for a fact, because we don't. According to relativity, you can't.
All right. So that's precisely the quotation that I was thinking of when Einstein, that I think is misinterpreted, because if you go later in that same speech, Einstein clearly states that the Earth goes around the sun.
Next sentence.
What I believe he means is he is talking about the strong equivalence principle, or what is now known as the Einstein equivalence principle. You cannot tell the difference between the Earth going around the sun or the sun going around the Earth. Ultimately, the two are equivalent. That's basically what he's saying. That is my interpretation of that quote, given what I know of GR. And so, I don't see how, I don't agree with that sort of interpretation. And even if Einstein said it, he was wrong. We can make observations that say that the Earth is moving around the solar system, going around the sun. Well, really, the sun and Earth are going around each other with respect to a certain barycenter.
But can we though? Can we though? Like I've found zero exclusive evidence. I get you'll say maybe aberration or parallax, but those aren't exclusive to the Earth moving around the sun. So if I look at the preponderance of evidence, it's actually overwhelmingly in favor of geocentrism. So we look out, we're like, oh, the universe must be expanding away from us in all directions, and it just makes us look like we're at the center. Now, mind you, that was not the initial prediction. It's actually the opposite. So they just take the geocentric position, say it's actually heliocentric. And it's same thing with Michelson-Morley. They were supposed to get a fringe shift. They didn't. It's just going to look like we're at the center. It isn't just about the ether. It's about the fact that Earth is supposed to be moving around the sun. And it wasn't measured to. So what has happened throughout history is that the goalpost keeps shifting to where the heliocentric model comes up with a theory to say, oh, it's just a stubbornly persistent illusion, to quote Hawking, to make us think that we're in the center. And I find that to be disingenuous, that people they act like it's just sewn up. We tell children, we know for a fact they're a tiny speck of dust and that they could die at any moment. An asteroid could hit them and it killed the dinosaurs and all this weird stuff. And I don't see the evidence for that. We can maybe get more specific, right? If you want to have more of a specific convo, but for example, here's what I don't understand. The modern cosmology is like the cold dark matter, right?
Yeah.
Like lambda cold dark matter.
That's the most
popular.
Yeah.
So the idea is that everything expanded from a single point. If everything expands,
kind of.
Well, it's a singularity. It's a single point, and then everything expands.
Yes, but the thing that I would caution folks against, because again, some folks have basically taken that and assumed that we are expanding into something, and that is a false assumption. That is not what cosmology teaches us.
No, you're right. Yeah, that's another paradox that you guys have. But real fast, if we have a singularity and we're expanding in all directions, I mean, nothing cannot exist, so we can't be expanding into nothing. But I mean, people believe crazy things nowadays. So we have a singularity, we're expanding in all directions. How is there not a center? How would it not be the center? If there's a starting point that's a singularity and everything expands out from there and it's still doing so, then that would be the center.
So again, from if you were saying that something that is expanding and there has to be a center, you are basically inferring that there is some outside frame or outside space that you are looking down onto the universe for. My favorite example, and I don't really have a better one, is the balloon example. Is you imagine that you are 2D, that you live in a two-dimensional space, and that is the skin of the balloon. There is no up and down at all. So you are simply on that balloon. If you put dots on that balloon, or if you travel from one dot to the next, you're going to do so at a certain distance. But as that balloon gets inflated by some divine being, then those dots are going to move away from each other. The surface expands, but there is no center, because on the skin you can go anywhere you like. There's no center to the skin of a balloon or the surface of a sphere. So
I get the concept for sure. Same with like a loaf with raisin bread, but Yeah, but that's just a cool story, bro, right? Like, the prediction was not that. The observation showed that. They moved the goalposts. And what it's turned into now is everywhere you're at, it's going to look like you're at the center. That's convenient. And now we have an accelerative expansion in all directions. And now there's a ton of energy that needs to accelerate it. And it's accelerating faster than the speed of light. But somehow it's okay because it's not actual information. It's just space itself expanding into nothingness. That's a cool story, you know. Do you see how they do just constantly move the goalposts? I get that you might think it's science, maybe like that's how science works, right? Like that we constantly figure things out, I guess would be the disagreement here.
Yeah, my question is, you keep using the term they. Who is they?
Just the collective, like the conglomerate of consensus, because that's how astronomy works. I mean, there's disagreements within it, but there are things you don't question. I know this for a fact because, like, I know someone who tried to get a geocentric paper published, and his math is bulletproof top to bottom. And they published the first one because it's just bulletproof. Then he publishes the second one. They're like, oh, wait, is he like actually trying to suggest that it's geocentric? Not getting published. You can't even question it.
So I don't know where that's coming from. I don't know that paper. I've never heard of anyone seriously suggesting that we live in a geocentric universe. That simply from a geocentric standpoint, that is, I have to say, settled science since Kepler. We've tried we've tried a Ptolemaic system, trying to explain the orbits of the planets going around in the night sky. It just doesn't work. The observations don't match. Tycho even decided, oh, wait a minute, let me split the difference. Let me say that the everything revolves around the sun, and Earth is at the center, and he actually hired Kepler in order to prove that, and Kepler couldn't. So the Tycho cosmology is thrown away. Now, the thing about moving goalposts is I don't quite understand that sort of that train of thought, because, you know, why would we make our lives harder? So we thought we had a very good grasp on cosmology prior to the observations of the supernovas, the type 1a supernovas. So why is it that we would, you know, basically invent that? Because it sounds like you're saying that we're inventing stuff, which we're not. We're simply doing observations. We're doing experiments to do that. So to show that. And I just lost my train of thought. And something else from before, which kind of goes into the whole they thing, is that you stated before with Galileo and Copernicus that it's revisionist history. Again, who is doing the revising?
Good question. That's what I want to know. Why have you never heard of the letter? Why are you an astronomer and you've never heard that Galileo like disavowed heliocentrism on his deathbed? Like provably so, verifiably his writing. Like that's what I mean. Are we going to pretend? Yeah. Wait. Oh, yeah. The Rockefeller Foundation alone would allow it. The Rockefeller Foundation owns basically all textbooks. They run all curriculum. So, that I don't think the astronomers are in on that, you know. But like they're growing up in a system that they learned from the curriculum. So the Rockefeller Foundation alone would show that you could easily revise history. And we know they revise history. They told us Christopher Columbus discovered this place. So it's revisionist history and the idea he used a globe to get here and he didn't. He got lost, but it proved the globe or whatever. But like, I guess what I'm trying to say is outside of that, I use the word they for just intensive purposes, but I'm not sure if you fully looked into it, right? But a neo-Tychonic system is entirely viable. A neo-Tychonic system. And there are multiple astronomers in the last 20 years who have come out and straight up said that, explained it. I could read some of them here, but you have Fred Hoyle. You know who that is? That's older.
Oh, yeah,
Fred Hoyle.
I know Fred Hoyle. Well, I didn't know him, but I know him.
Martin Gardner.
I have him to thank for the Big Bang.
Yeah.
Thanks, Fred.
Yeah, he made fun of it. Yeah, but Martin Gardner here is talking about a neo-Tychonic system. Okay, here's another quote from Carl Wolfman, right? Because you mentioned back in the day how they basically verified it was heliocentric. I tell my classes that had Galileo confronted the church in Einstein's day, he would have lost the argument for better reasons. You may use my name if you wish. This is because of stuff like Michelson-Morley. See, like, Kepler didn't come up with anything. I mean, sure, he was, Tycho was his tutor, and he saw him promising whatever, and he ended up suggesting that we were in a heliocentric model and that it all operated on acoustics, but that's just it was just a kinematic drawing. It wasn't like physics. He definitely didn't prove anything at that point because it was just kinematic. You know what I'm saying? And you get up to Einstein or Newton, he offers dynamics. It doesn't work. It doesn't work.
Oh, yeah.
No, go ahead.
I just wanted to revise something. Tycho was not his tutor in any way whatsoever. He was his boss. He would be the modern day equivalent of a PI or principal investigator and a postdoc. He hired Kepler specifically because Tycho could not get the math to work for his own cosmological system. And it was only after Tycho died and Kepler basically stole the data that Kepler was able to complete his work on the three harmonic laws. Are they physics? I mean, that's an argument. That to me is sort of a philosophical point. Those are empirical laws. What he did was he looked at where the observations of Mars had been, and then he fit a pattern to it. And that pattern was an ellipse of a certain eccentricity. And from there, he was able to derive his first law, which is that all planets go around in ellipses. The second law, which is that equal areas and equal times, basically it's conservation of angular momentum. Planets slow down when they're far away from the sun, and they are faster when they're closer. And then his most famous law, the harmonic law, which states that the period of a planet with relation to the period of the Earth squared is equal to the semi-major axis of that planet to the semi-major axis of the Earth cubed. And in a wonderful synergy between empirical observations or empirical study and theoretical study, Newton then was trying to figure out a way to test to see. He had this inkling that the moon, for example, was held in place by gravity. And he wanted to test that. So where better than Kepler's laws? And he was able to derive from first principles using his idea of gravity that he actually derived Kepler's third law, but made it even more generalized. What Kepler couldn't realize was, because of his ratios, was that there are constants in there. There's the 4 pi g, and then there's the mass of basically the two-body system. All of that drops out in the planetary orbits. So I think that's an excellent example of how we're not just sort of guessing or imposing things onto history or onto people. We are, Newton derived it from first principles. But, Kepler's whole harmony of the spheres thing, yeah, that's kind of Woo Age garbage, in my opinion. Newton's problem with gravity or at action at a distance, yeah, he didn't like the fact that gravity seemed to behave that way, but it didn't make him not think gravity was a thing.
Yeah, he said there could be an ether, and he said the Earth could be at rest. So that's what Newton said. Newton said the Earth could be in the center, and he didn't propose a mechanism, anything like that. What's funny is people still to this day, they're like, Newtonian mechanics works just fine. No, it doesn't. It doesn't work outside the solar system. It doesn't work in principle outside the solar system. So, like, even in theory at all, period. It doesn't just fall apart because of the bigger scale. It just doesn't work because of what he introduced. He introduced the fictitious forces with an absolute background in space. An absolute fixed space doesn't work outside the solar system. Newton's not even on the table as viable at all whatsoever. You have to have Einstein. The only reason he was considered viable for so long is everyone assumed there was an ether. And that's the only reason you could even begin to act like you're using Newtonian mechanics. And, like, according to him, if there was an equal and opposite force, then the Earth could be at rest. Well, we know, as of course, even using his own framework, if that everything was moving around the Earth, like everything, that would create a centrifugal force, that would create a Coriolis force, you would have a net centripetal force, and that would cause the precession of the pendulum, that would cause the sidereal rotation detected with the ring laser gyro. According to Newtonian mechanics, you can't invoke the pendulum or the gyro as proof that we're spinning. So Newtonian mechanics really only kind of benefits geocentrism at this point. It doesn't help heliocentrism because you can't even apply it outside the solar system. I guess what I never have understood about this is a really basic level. Geocentrism doesn't have the problems that heliocentrism does. It's easier math. It's simpler and easier math on the very first step. Basically, it's just easier. But it doesn't work. So we have dark matter and dark energy. We don't have that problem with the geocentric position, though. So how long are we going to pretend like that's not a big deal? Geocentrism doesn't have the problem of dark matter and dark energy, but heliocentrism does. So how does that not make geocentrism more viable? And why is it not even being considered? That's what I don't understand. Is there some exclusive definitive evidence that's proving heliocentrism or something? Because it's not even allowed to be considered and it's more viable. I've never understood that.
Okay. So, I don't know where you get, well, all right. So I'm going to have to ask at some point for you to detail what you mean by geocentric system, because the geocentric system, by sheer motion of the planets, doesn't work. There is no model where you can accurately predict where the planets are going to be in the future using a geocentric model. And as for the math being easier, that is patently false. If, again, assuming you're talking about the last geocentric model that I'm aware of, which is the Ptolemaic model was god awful. It had 60, you had to account for 60 epicycles. That was one of the, like I said, that was one of the reasons why Copernicus rejected it, or not rejected it per se, but he went off in a different direction, put the sun at the center. He also had some religious views as to why that was the case, but that's beside the point.
Yeah.
The other thing is, I can tell you that Newtonian gravity is still used in all or a lot of different aspects of astronomy. The first one I can think of, and also in relation to dark matter, is Vera Rubin when she looked at the rotational curve of one or group of spiral galaxies. I can't remember which. May have been our own. She basically was using Newtonian gravity to determine the mass based on the observed velocity. And she saw that the rotation curve of galaxies was flat, which only makes sense if the galaxy is in fact similar to a merry-go-round, in that the mass is fairly evenly distributed over the course of the object. If the galaxy was more solar system-like, where most of the mass was concentrated in the bulge and it petered off in the disk, then you would expect a Keplerian curve where the velocity would drop as a function of distance. So Newtonian gravity is often used in astronomy all the time. And I also don't understand what you mean, again, probably because I don't understand what you mean by geocentric system, how dark matter wouldn't be a problem. Because we see dark matter effects. We have observational evidence that there is missing matter in the universe. We now have observational evidence of dark energy. So whether or not it's so I would be curious to know how geocentrism would explain either of those two concepts.
Okay. For one, Vera Rubin saw that the outer edge of the galaxy was spinning just as fast as the inside of it, which actually violates Newton's laws of motion. That doesn't help Newton. That's terrible for Newton. And this is why you need dark matter to fix it. It does. You can't have the outside of it spinning just as fast as the inside, according to Newton's laws. But when it comes to the dark matter, dark energy thing, if the Earth is geocentric, then the universe can be much more local, much more dense, much younger. So you would just have like a more dense composition. You don't need accelerative expansion, so you don't need dark energy whatsoever. And dark matter is just based on the current gravitational theories and assumptions that we don't even need. You have vast distances, vast mass distribution claims, and all this stuff, where 84% of it is something that you can't define. I don't see how we could have directly observed something that, well, we didn't directly observe it. When you say we observe it, you don't mean observe it, right? Because it doesn't interact with the electromagnetic spectrum light, so we can't observe it. We can't define it. It's just like a mathematical plug for the model. I mean, that's another example where it even starts in 1933, and they looked at the galaxy clusters, and the galaxies should have been escaping the clusters because there was only 1% of the mass that gravity predicted. But they just said, oh, never mind, we'll just say that there's something else there, 99% there. So I know I've heard, the first time I'd ever heard really your claim, maybe the audience would like to hear of what you think dark matter could be. Because I don't, unless you want to respond to what I just said, of course. Like,
well, I do, but I'll lead into the second one. Yeah.
Okay, good.
All right. So with Newtonian mechanics, as I described, specifies that if you have an object that has mass evenly distributed, then your rotation curve is going to be flat. If you have mass that is centrally concentrated, like the solar system, then the disk is going to fall off in a Keplerian way, p squared over a cubed kind of way. So Newton predicts both of those. So it's not a problem with Newtonian gravity. And, again, so Vera Rubin's observations, the problem was that that there was dark matter there, or there was matter there that couldn't be accounted for. Your observations that you quote in the 30s, I believe those are from Fritz Zwicky, who was a very interesting individual. I think one of the reasons why he was disregarded is because, well, he was kind of an asshole. He threatened to shoot one of his co-authors. So there might have been some kind of personal grudge there. In terms of dark matter, there are two, and I hate these acronyms, but there are two competing camps. There are those that are machos, massive compact halo objects, and then there are WIMPs, weakly interacting massive particles. One of my colleagues at Georgia State, he is firmly in the macho camp. He believes machos are normal baryonic matter that is simply low luminosity, meaning that it's just not bright. And as is often been touted, you have the inverse square law of light. So if you have a very dim object that's very, very far away, you need exceedingly sensitive equipment in order to actually see it at all. But from a gravitational standpoint, you can notice its effects. So machos, their explanation is that what we're seeing are just really low mass stars, or dark matter is really low mass stars, exoplanets, white dwarf remnants, neutron stars, black holes, that sort of thing. So there is a camp, although the evidence is moving against them, but there is a sizable camp in astronomy that believes that dark matter is in fact normal baryonic matter. It's just really dim. WIMPs are weakly interacting massive particles, and so there you have essentially kind of two camps-ish. You have the camps that believe that the best explanation for dark matter is neutrinos, which are massless particles that have been detected. The only problem is that they are very, very high energy, and what the models are telling us is that dark matter needs to be cold in order for things to work well. And then you have in the other camp in the WIMPs, which I have not studied very well because so far they haven't detected any of their exotic particles like axioms or what have you. Until they actually find something, I'm really not going to invest myself into looking into it. So that's basically the current state of dark matter in astronomy.
Yeah, so I just made up. No disrespect, but it's just made up stories. That's what that is. Like, oh, well, maybe it's just there's matter there. It's just invisible, or it's that's a cool story. There's no evidence for that, and there, I guess you would automatically have to disavow any type of claim that says that they're able to find some of it on the Earth or anything like that, right? Like a CERN, all these stories. Obviously, any belief that it's baryonic matter you would have to disavow all claims at CERN, claiming that they are able to like briefly concentrate dark matter, which is pseudoscience. So I would of course agree with anyone disavowing it, but so 84% of the matter in the universe is really dim matter that you just can't see. Another major problem, there's so many problems with heliocentrism as a bias. So like the whole universe has to accelerate. And for the audience that doesn't know, right, that wasn't the initial prediction. We were supposed to see chaotic stuff happening all over the place. We're just a tiny speck of dust out here observing everything around us. But everything's moving like we're in the center. Then they came up with the balloon analogy that he said. Basically, like there is no center. Everyone's going to look like it's the center, which is convenient. And so now everything must be accelerating away from us, expanding in all directions. And so we fast forward to now. And so you have the cosmological constant, and then you have the Hubble constant. And we have these don't work at all. So we have what's it called? The Hubble tension, right? Though the Hubble tension is this huge discrepancy between like the predicted value based, or I guess what they call it, the measured value on like the closer galaxy scale, right? And then like these observations of supernovas, and the rest of, and the cosmic microwave background and stuff like that. When they combine these two, the discrepancy is huge. What is it, like 60? It's almost like 10 kilometers per second per megaparsec off. It's like 60. Yeah, it's like 67 to 78 or something like that. So that's a lot.
Closer, but yeah.
Well, yeah. So it's wrong. It's drastically wrong, and so none of it works. I don't understand. Okay, maybe you can help us understand the Hubble tension. Explain to us what that is, and I'm going to be dissatisfied with. It must just be that our measurement devices aren't good enough. But if you can kind of explain maybe what you think about that, because yeah, or the audience may not really even know what the entire basically you have the idea that the universe is expanding in all directions, and you have the idea that a certain amount of energy has to exist to make this happen.